Hi everybody, we are continuing our discussion of the skeletal system today. So this is the same notes that we had looked at yesterday. We're just going to jump down to slide 17 today. So we are going to look at the microscopic anatomy of bone. This is built out of these structural units called osteons. So I think they look like little tree trunks. If you sliced a tree, right, you get to see the rings, same idea. So don't worry about this vocab for now, but you see this kind of hole in the middle and then these layers built around it. So an osteon is a basic structural unit of, and really this should say compact bone, because that's what we're looking at here. All right, some things to talk about regarding bone is that osteocytes or bone cells are living cells. So they need nutrients, they need oxygen, they need to get rid of waste, so they need a blood supply. Inside your bones, your compact bone, you have these two canals that bring in blood, take out waste, and there's also nerves in there as well, right? I've never broken a bone, but I've heard it's painful, right? Your nerves are there, to tell us if there's something wrong with our bones, right? It hurts. So the central canal, that's that big circle, if you look back in that picture, in the middle of an osteon. Some of this is old terminology, guys, so you may have seen Haversian canal before, but we are going with the term central canal. So that has a main blood supply coming in. And then perforating canals are perpendicular to the central canal, and they also carry blood vessels and nerves. So if we look at this diagram, this is diagram 5.3 in your textbook. You will have the same diagram on your test. It's a lot to look at right now, but I just want to look at kind of the overall structure for right now. So you have these circles, right? Each circle is an osteon. So your compact bone is made out of many, many, many osteons, smushed in there together. And then going straight down through that osteon, you have a central canal, right? Bringing in the nutrients to the bone cells. And then I don't really like this part of the diagram. If you look down here, perforating canal kind of points to this, I don't know, it kind of looks like an armpit over here of blood vessels. It's this whole structure going across. So the whole canal here going perpendicular to the central canal, that's called the perpendicular canal. You can see one here, you can see one here, and then there's one over here. So those are perforating canals. They're perpendicular. Whole purpose, blood supply. All right. If we go back and look at our osteon, so imagine, right, our osteon was one big circle, and we took like a slice of cake out. We're gonna see, the central canal is here, and then there's all these layers or circles within circles that make up the osteon. And those layers are called lamellae down here, from the Latin word for layers, right? So they're rings or concentric circles around that central canal. In between those rings, you have these little spaces or cavities, I think of them as little caves, where the osteocytes live. The actual bone cells are stuck in between those layers, and they live in these little holes, and that's where they spend their time. These layers, by the way, right, they're made of calcium phosphate, so they're pretty solid. That's what bones are made out of. So there's tiny little spaces in between them. Those spaces are called lacunae, and that's where your osteocytes live. All right, in between those layers, in between those osteocytes, if you look, you have these itty bitty tiny little canals, these tiny little lines that connect one bone cell to a next, or one bone cell to like the next layer. Those little tiny lines are called canaliculi. They're hard to see sometimes depending on the micrograph that you see, but they're called tiny canals, and they go from the central canal, from cell to cell or from layer to layer. And it says they form a transport system, which is true. So you have this central canal, you have blood coming in with nutrients. Those nutrients have to get to the bone somehow. They travel down these little lines, right, from layer to layer, from cell to cell. So nutrients can get in there to those osteocytes because they're stuck. All right, we're gonna draw all of these things that we just went over super briefly. We're gonna draw in a minute, but I want you to be aware of some bone-related terms. So these are all different cells that have to do with bone tissue. Osteo means bone, right? So osteogenic cells are the stem cells that eventually become bone cells. We're gonna look at kind of a balance between a couple of them later on this week when we talk about homeostasis in the skeletal system. I'm just going to throw them at you today though. So osteoblasts are bone-forming cells. They are the ones that secrete the minerals of the bone, the calcium phosphate that makes it super solid. So osteoblasts make that matrix or that mineral, that calcium phosphate, but eventually they get stuck. So they're secreting all that super hard material and they get stuck in it. Once they get stuck, we call them osteocytes. So when we're looking at osteons today, we're looking at osteocytes. They're stuck in their little lacunae. Like I said, we'll look at kind of a balance between bone-forming cells and bone-dissolving cells later on in our unit, but for now, we'll just mention that your bones are constantly being formed and reformed throughout your life, depending on hormones, depending on diet, depending on physical activity and lifestyle, genetics. So we're looking at the balance between these bone-forming osteoblasts and these bone-dissolving osteoclasts. There are reasons that your body wants to have osteoclasts. They form a purpose, and we'll look at that later. So for now, we're just looking at osteocytes, the bone cells that are trapped in our osteons. So we are going to draw this together. I'm going to switch gears here. If we were in person, I would draw this with you on the board, but I'm not here today. So we're going to draw this together. All right. So first off, let's draw an osteon. So I'm just going to take some circles. We'll start with that central canal that houses blood vessels and nerves. And then I'm going to draw some, that was a little bit bigger, concentric circles to represent the layers right in between. This is not perfect. Yours does not have to be perfect either. So we have layers and layers that make up our osteon, right? The functional unit of bone. All right, so first off, let's take a look and do some labeling. Right in the middle, kind of in the middle on mine, we have the central canal. Right, so I'm coloring that in red. You can make it any color you want or just label it. But the central canal, right, that's the part that houses the blood vessels and the nerves. And then the concentric spaces of calcium phosphate that make your bone super solid, right? That matrix, the mineral matrix of your bone. Each circle represents that. Those are the lamellae. So layers and layers of your compact bone. All right, and then in between those layers, do your best here, guys. Draw a few. I want this to be black. You can make everything whatever color you want. So you have these little spaces that are eventually going to house, we'll draw some osteocytes in there, but they live right kind of in between those layers. They're going to be found all over the place, stuck in between those layers. So draw some in there. And so those are representing our lacunae, the little caves that our bone cells live in. All right, and those little caves are called lacunae. Right? Not super great on mine. You can draw them in at all different angles. Right? They're all over the place. So you saw some pictures earlier, and we'll look at the diagrams again here too. All right, so we have those lacunae, the little caves. Inside those caves, we have the osteocytes themselves. So, it's supposed to be in there. There we go. So the osteocytes live in the lacunae. They're stuck there in that calcium phosphate. That's where they're going to live. All right, again, so those are going to be called osteocytes. And then connecting, outward from the central canal, from bringing that blood vessel, the nutrients from the blood vessels outward, you're going to have those little lines that connect layer to layer, or cell to cell. They kind of radiate all over the place. I'm not going to draw tons of them, but you sure could, right? So they kind of radiate outward, bringing the nutrients from that central canal all the way out to the osteocytes. And so you can draw them all over the place. I feel like I could go crazy just drawing these all day. So again, I'm not drawing a ton, but you sure can. All right, so again, those are called canaliculi. Tiny, tiny canals. All right, so guys, this is our basic osteon. Mine looks a little bad, but you still get the idea. This is when you're looking down from like a cross section across, a femur or something. So compact bone, you can see one osteon, one structural unit. But these, do not live alone. So, all right, so if we look at it from the side, that's a little close. We have, so totally kind of separate thing here. You have an osteon, if we look at it from the side, the central canal in the middle, right? And then you have the side of it here, and then it's going to live, next to another one, so, and there might be one right next to it. It's going to be a whole bunch right next to it, right? They're kind of stuck in there right next to each other. That one's going to have another central canal down the middle. So the central canal, and this is not perfect here, guys, goes down the middle of the osteon, right? So it goes straight down, right? You'll have another one here going straight down. Those are central canals, and then connecting them, going perpendicularly, is going to be our perforating canal. So I'm going to make that another color. It doesn't have to be, but I just want to differentiate it, right? They go perpendicular to the central canals. They're helping carry that blood supply into the bone and from one osteon to the next, right? So in regular old, compact bone, you are going to have lots and lots of osteons kind of butting up against each other. And so you'll have one here. You might have one like right next to it here. They don't have to be the same exact size or shape either, right? Some of them are, a little oblong. They don't necessarily look like perfect circles. So you're going to have a whole bunch here, and then you'll have extra lamellae kind of filling in the gaps in between. It's called interstitial lamellae. So in between the osteons, it's all filled with tissue, all filled with calcium phosphate. All right, so I'm jumping back to our regular diagram. This is straight from our book. You can see the osteons next to each other, the central canals, the perforating canals. If you use your imagination, right, kind of stare at it closely, you can see the little spaces that house the osteocytes, the lacunae, and then it's really hard to tell here, but you have, zoom in on it, you can see the canaliculi connecting one layer to the next. The blood vessels that are housed in those perforating and central canals that come, they eventually came from the outside, that nutrient artery coming to the bone. So that is our osteon. Lots of vocabulary, guys. I think try to draw it a couple times, color code it, get some practice with it. But that's compact bone, what it looks like microscopically. Thank you.